Okay, hi, this is part 4 in sequences, which should be the final part. What I'd say first, might help you have a go at this starter question, just so we get a grip on how the more exams questions can be worded. So I'll pause this, give it a quick go, and let's go through it together. Okay, here we have two different geometric sequences. So let's write down what we know. So for sequence A, I'll call it sequence 1. We know A is the first term and the common ratio is 2. For sequence 2, we have a first term of B and a common ratio of 3. We're then told the sum of the first 4 terms of both series is the same. So using this formula, the sum of the first 4 series is going to be given by this. And for my other sequence, it's going to be given by this. Okay? And we know that these two things must equal each other. Oh, that should be a B, not an A. Okay, we then need to somehow get this result here. So let's write that as an equation. We know that A brackets 1 minus 2 to the 4 over 1 minus 2 equals B 1 minus 3 to the 4 over 1 minus 3. That's a bit of a mess. So let's work out everything we can do, which gives me this. 3 to the 4 is 81, so that's minus 80. Let's get rid of my double negatives. So I now have 15A equals 40B. It wanted it in the form of A equals. So A is going to equal 40B over 15. I have a common factor of 5, which gives me 8B over 3. Okay. This was a starter because that wasn't too bad. However, it looks horrific. So with sequences, that is the current game the examiners are playing. They're giving you questions that aren't too bad, but look really, really bad. So my advice is trust the formulas, try the sensible things, be careful of silly mistakes like I nearly made here, and then take it from there, and it should hopefully all come out in the rain. Okay, we have the final thing we should cover, which is iteration sequences, which use this kind of inductive notation, which basically means each time the term depends on the previous term. So this you've seen a bit of GCSE, but we'll go through it again anyway. So here, you're told what the first term is. You're also told how, if you have a term, how to find the next term. So this is basically the next term, and this is the current term. So if A1 is 4, then to find A2 is just doubling A1. So therefore A2 is going to be 8. To work out A3, you just double A2. We know that A2 is 8, so therefore A3 is 16, and so on and so forth. That is it. So you basically only work out the next term if you know the previous term. Here the same idea. Some sequences start from A1, others start from A0. It doesn't really matter in the slightest. Okay. So to work out A1, I do the previous term, which is A0, and take 3 away from it. A0 is just 7, so therefore A1 is 4. To work out A2, I get the previous term, so A1 and minus 3 from it, and A1 was 4, and 4 minus 3 is 1, and so on and so forth. Each time it's taken away 3. These are really simple examples, okay, to give you the idea of how it works. Let's look at one that's slightly harder, and see what the questions look like. So here we have basically a more complicated rule. The bit complicated as I like, they tend to get a bit worse than this, but it's just calculate work for the most part, so it doesn't affect too much. So to work out my second term, I need to do 6 minus 2 lots of U1. So 6 minus 2 lots of 1, so U2 is going to be 4. To work out U3, I do 6 minus 2 lots of the previous term, which was just 4. That gives me minus 2. To work out U4, I do 6 minus 2 lots of the previous term, which is minus 2, and that gives me 10, and so on and so forth. That's the basic idea, okay? When I taught this in the past, I recommend using the answer button. So you can log 1 as your answer, and then just type in the right-hand side over here, replacing UN with the answer button. So U2 was 4, U3 was minus 2, U4 was 10, and each time you press equals, you'll get to the next term. So it makes it really easy to work these things out. Okay, that's the basic idea we should kind of know already. You can just go to the books and have a go at these questions. Don't try them all because a lot of questions in this question 3 is a bit weird and not too related to what the exams will tend to test you on. Okay, they are some harder questions, so these aren't too bad. Okay. Give them a go. You might have to harder questions 5, 6, and 7, but again, the answers are here in this link. Okay, moving on. You are asked basically what kind of sequence you might have. Okay, they are technically 4 main type of sequences. You have increasing, where each time the sequence gets bigger and bigger. You have decreasing, where it gets smaller and smaller. You have periodic, where it loops, and you have the 4th type, which is other. It's basically anything that's not increased, decreasing, or periodic falls into the basic catch-all category. The one we care most about and most useful in terms of a maths point of view are periodic sequences, which we're going to look in now. Okay, so as a brief example, if we square it to minus 1, square the previous term minus 1, you basically get stuck in a loop. 0 squared minus 1 is minus 1, minus 1 squared is 1, and then take away 1 is 0, and so on and so forth. They keep repeating. These questions tend to come up most often in exam papers, so we'll spend a bit of time looking at them now. So I'm going to go through this one exam style question. I'm going to try a couple that are kind of similar on the same veins to it, to basically see how hard the questions can get and what they tend to look like. So we have this iterative formula, and we have an unknown in it k, which is very common. If you don't do that, you tend to be surprised. First part is a show that question, and again, show that questions come up a lot more in exams these days. We want to show that U3 is given by this form here. So let's work it out. So to work out U2, it's going to be 3k minus 3. Again, replacing both the UNs with the 3. Expanding it out is going to be 3k minus 9. For this, always expand when you can, especially when there's no brackets here. Now we work out U3. So that's going to be U2, k minus U2. Replacing U2 with what we know it equals. So we have 3k minus 9 brackets k minus 3k minus 9. So here, a bit messy with the old brackets. Let's have a go at it. So first, I'm going to sort out this bracket here before I times them all out. So I have k minus 3k, which is minus 2k. You also have minus 9, which gives me a plus 9 here. Okay. If you prefer, think of that minus as a minus 1 times that bracket. Maybe make that a bit more straightforward for you. So we now have that times 3k minus 9, and we just expand it all out. So minus 6k squared. We then have 27 plus 18, which gives me 45k, and 2 9s are 81. And that is the same as this. So now on to the interesting part. You were told this sequence is periodic with order 2. That means every second term will be the same. So it's saying if U1 is 3, then you must have U3 to be 3 and U5 to be 3. That's what periodic with order 2 means. Again, if it's order 3, it'll be every third term will be the same. So then U4 will be the same, and U7, and so on and so forth. So we're told the sequence is periodic with order 2. And then we need to explain why k equals 4 is not a solution. So here we're going to start with this part here. We know it's periodic. So that tells us that U1 equals U3. We also know that U2 equals U4, for example. But it's always easiest to use the smaller terms, the earlier terms, because they're more simple terms. So we have this relationship that u1 equals u3, and we're going to write that down. u1 was just 3, and u3 we just worked out. So notice here, this is a show that question. That is so in case you mess up part A, you can still basically attempt to get marks off part B. Hence why show questions are more popular in exams nowadays. So we now have this equation that we are going to solve. So let's make it equal to 0. And this we can just solve by the quadratic formula or asking your calculator to solve it. Okay, so we go ahead and do that. I'll skip ahead to the end of this. Okay, so solving that, again, it's selection of both sides of calculators. We get two solutions. We have k equals 4, or we have k is 7 over 2, or 3.5. And we are told to explain why k equals 4 is not a solution, which is really weird, because we've worked out that k equals 4 is a solution. That gives us u1 is u3 is the same thing. So what's going wrong here is not a simple question. And it basically turns out that what I said over here, that u1 being u3 being u5, that isn't always period of order 2. There is another solution here of it not being period of order 2. For this to be periodic of order 2, you must have that u2 was not 3. And also u4, again, would not be 3. That is the true period of order 2. What we could have had is that every term was 3. That's a 4. If every term was 3, then that is not periodic of order 2, that's periodic of order 1. Okay, or just all the terms are the same. So when it says k is 4 is not a solution, that's probably what it's talking about. So we need to test this. Does k equals 4 give us all terms being the same or not? Well, let's work it out. So I have this formula here. I know u1 equals 3. I'm going to write my relationship as this with a 4 now. And I'm going to work out what is u2 going to be. So u2 is going to be 3 times 4 minus 3. 4 minus 3 is just 1, and 3 times 3 is 3. So here, every sequence would be equal to 3 if k equals 4. Hence, that is why that is not a solution. You would say literally that. Every term would be 3. So k equals 4 is not a solution. Part C, hence work out the value of k that results in a period of 2. That's going to be my other value, 7 over 2 or 3.5. Okay, then we have part D. Out of all of this stuff, part D is probably the most popular to come up in exam questions. Hence or otherwise, work out the sum of the first 100 terms. Now at first glance this is possible because you only work out the next term by knowing the previous term. However, because you have period of order 2, it makes it possible. Let's show us how. Let's just list the first few terms. So u1 was 3. u2 is now going to be 3 times 7 over 2 minus 3. That's going to be 3 times a half, or 0.5, which gives us 1.5. So u2 is 1.5. Let's work out u3. Now we certainly hope this is going to be 3 again, so period of order 2. 7 over 2 minus 1.5. So we now have 1.5 times 2, which is indeed 3. So u3 is 3, which means u4 is 1.5, and so on and so forth. So because these terms keep repeating, keep cycling, we can then work out what the first 100 terms will be. Because we know that every 2 terms together are going to equal 4.5. So if every pair of terms equals 4.5, and we're summing over 100 terms, that therefore means this sum is going to be 4.5 times 50, because we have 50 pairs in 100. that will give me the lovely answer of 225. Okay, a lot to take in there, but again, it's pointless if you don't prepare these up to A-level standard. Okay, so on the next page, you have a couple questions for that exam style. Use the same idea, and again, another question taken from a previous year exam paper. All of them use roughly the same ideas I've just gone through, so there shouldn't be a massive stretch. Okay, once you've done that, there's then one more section of this chapter. That is looking at the modelling questions. So again, on the next page of the OneNote, again, answer this wee little link here. Just trying from questions 2 to 9. Okay, you can try more if you want to, but they're all roughly the same. It's just working out whether it's arithmetic geometrical recurrence and then reading the question carefully. So I won't talk through it, but you can go through it more if you want to. Okay, hope that helped, and thanks.